Okay, let's do 2.8b as in boy on linear inequalities. The second video, we're on example 6, and we have 2.5x minus 3.48, and we're saying that that is less than negative 4.9x plus 2.07. Alright, so we've got a couple different methods that we can do this. With the use of calculators, using these decimals isn't any problem at all. So the second method isn't really a whole lot of value, but what they do is they look here and see which of these numbers has the most digits to the right of the decimal sign. This one has 1, this one has 1, 2, this one has 1, and this one has 1, 2. So the ones with the numbers, the most numbers to the right of the decimal point is 2. So if I multiply this entire thing by 2 zeros and put a 1 on it, that will get rid of all my decimal points. So if I multiply the 100 times this, it becomes 250, and this one becomes 348 is less than negative 490 plus 207. So I got rid of all of my decimal points, and I can go from there. The other way is just to leave the decimal points on there and just use your calculator to add and subtract the decimals. So that's what we're going to do here. So let's see, what do we want to do? We want to add 3.48 to both sides. I'm just moving things around so I can get my x's by itself. So let's leave everything else alone. And then that will give me 2.07 plus 3.48 is 5.55. Alright, let's add this to both sides to get rid of those. So we get all of our x's over here on the other side. 7.4x is less than 5.55. Alright, now we're going to divide by 7.4 here, 7.4 here. Those go away, and we have x is less than 0.75 when I do this math in my calculator. So set builder notation. And graphing. So 0.75, I can just put it wherever I want. And I'm going to make an open circle because of the sign here, and it says less than, so it's going to be an arrow that goes to the left. And I'm done there. Alright, example number 7. Example number 7 is 3 times x minus 4 is greater than or equal to negative 2. And we're just going to use our distributive property here. Add 12, add 12. 3x is greater than or equal to 10. So divide by 3, and x is greater than or equal to 10 over 3. So set builder notation. Ew, that's kind of a crummy looking parenthesis. Looks like that. And when we graph it, x is greater than 10/3, so we put a 0, we'll put a 10/3 here, and it's greater than or equal, close circle, and since it's greater, it's going to go to the right. And we're done there as far as example 7. So this is example 8. As we go along, they just get a little bit trickier and a little bit trickier, but you guys can do these. Less than 4x minus 14. Alright, so again, we're going to try to get all the x's on one side, but let's do this distributive first. Okay, now let's get the x's on the same side. So let's subtract 4x here and here. So we have 2 minus 10x plus 4 is less than negative 14. And we've got a 2 and a 4. We'll add those together. Subtract 6, subtract 6. So I have negative 10x is less than negative 20. And again, the signs are both negative, and we only have one term here and one term here, so we just take off the negative signs. But when we take off the negative signs, we change the sign. So, something to remember there, because actually what we're doing is, let me rewrite this here, negative 1 times 10 x is less than negative 20. So we're trying to get rid of this negative here, so we divide by negative 1, we divide by negative 1. So notice we divided by negative, that means our sign changes, and negative 20 over negative 1 is positive 20, which is what we got there. So that's the theory behind what we did. So when you take the negatives off the two terms, you have to switch the signs around. Okay, divide by 10, and we get x is greater than 2. Set builder notation. And a graph. Or an open circle. X is bigger than 2, so it goes to the right, and you're done there. Alright, so example number 9 is what we're going to be working on right now. And it says 2x minus 3y is less than 6, and we're solving for y. So really all we're doing is moving things around so that our y is all by itself. So let's take 2x away, and I get negative 3y is less than 6 minus 2x. And now I'm going to divide by negative 3, and the sign changes because we divided by a negative. And now I'm going to rewrite this as 6 over negative 3. Remember, I can split these up. And let's go minus 2x over negative 3. And we've got two negatives there, so that actually makes them positive. And I can actually erase that then. Okay, so 6 over negative 3 is negative 2. And we like to have the x's first, so I'm going to rewrite that as y is greater than 2x over 3 minus 2. So what I did is I just wrote that then, solving it for y. And at this case, you don't graph it, you don't write it in set builder notation, you can't. So we'll just kind of leave it alone as our final answer. Okay, so let's look at example number 10 and we'll be done. Now one thing that's important when we're doing these inequalities is that when x is 3, that means the answer is 3. But when it says x is greater than 3, that means x can be any number as long as it's greater than 3. It doesn't really matter. It can be any number. It can be all, in fact, it's all of those numbers. So when we're doing story problems, we'd have to remember that. So it says the sum of two consecutive odd integers. So consecutive odd integers, there's two of them. The sum of those, when we add them together, is going to equal 28. Is that what it says? At most 20. So it can equal 28, but it could also be, at most, it could be a number less than 28. 28 is just the biggest, when you add those up, that it can be. So it's either going to be less than 28 or equal to 28. And then I just take my parentheses off, add my x's, subtract 2, and I get 2x is less than or equal to 26. Divide by 2, divide by 2. X has got to be a number less than or equal to 13. So that is what I'm looking for. What are the possibilities for the first of the two integers? So that's the first of the two integers. 15 would be the next one, because when I add 15 and 13 I get 28. So those are the biggest numbers I can use. Now this could be a 9 and the other one could be an 11, because when I add those up I get 20. Well, that's less than 28, so that works. So x is 13 is the biggest number I can use for x, and then 15 is the biggest number I can use for x plus 2. So that's it for example number 10. And that's it for the videos for 2.8 linear inequalities.